Okay, good night, folks, and this is the May-June 2019 paper for physics. So I'm going to just answer the questions, and if you're brave enough, you can look at my answers and see, you could gauge and see how much you would have scored. I'm not going to say the paper was easy. I'm going to say the paper was actually fair. It was double because it's only easy if you studied, right? So here goes the x for x. X is just where the current is passing through because I put it at the two connecting points. So I would have said voltage applied, power source, okay, alternating current. So either one of these would have been fine, okay? Then it says Y. Y is the secondary coil. And then Z is the soft iron core. Soft iron core. This came on one of the exams. I think this came on 2000, what's this year? 2017. It was similar. And so if you studied from that or looked at my videos, you would have seen something like this. And this is actually a little more simplified than what the 2017 paper had. Now we're moving on over to graph, and the graph was nice. It was nice. So it says the transformer shown in figure 1 was tested, and the values for the primary voltage Vp and the secondary voltage Vs were obtained. The data is shown in table 1, and we have Vp, we have the voltage for Vp, and we have the voltage for Vs, and of course the units are volts. Then they said, using the grid on page 7, plot a graph of Vs and Vp. So they gave us the title for the graph right here, which is nice. Thanks, CXC. So now we're going to graph. So it says Vs against Vp. So this is Y against X. So anything in S, anything in Vs here is Y, and this is X right here. Okay, let's get started. Now we're going to look at the ranges. So for V, let's do X first because it's nice. So X goes from the range of 0 to 8. So let's just set 0 and 8. And I read through the question 1 to see if they said any y-intercept or whatever, and it didn't say that. So we could write a nice large scale, because when you do y-intercept, you tend to want your graph a little neater than what you would produce if you didn't have a y-intercept. So we're going to start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's 16. It goes up to 8, so we can do every 10. So 1, 2, 3, 4, 5, 6, 7, and 8. And this is all VP, our primary voltage. And we say in volts. And then here now we have our secondary voltage. Vs, and we're measuring in volts again. And so our range here is now from 0 to about 80. So we could go up in tens, because let's see if we have 10, 1, 2, 3. This is about 23 spaces. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20. It's perfect. So we could go up in twos. In two boxes are tens. So if it's a 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And if you've looked at all of my graphing videos, you would realize that how to calculate the spaces in between. So here we see that this is up in ones. Each of them are 1, 2, 3, 4, 5, 6, 7, 8. And between here, each of these are 0.1. So 0.1, 0.2. How you do that? You minus 0 from 10, divide by the 10 spaces, and you get 1. Or you minus 0 from 1, and you divide by 10, you get 0.1. So we're going to start to plot now. So when it is 1.5, which is in between here, when x is 1.5, the secondary voltage is 14, which is going to be here. So this is 15. When x is 3, the voltage is 26. When x is 5, the voltage is 45. When x is 6, the voltage is 53. 1, 2, 3. When x is 7, the voltage, well, x is 7.5, sorry. The secondary voltage is 67, 65, 66, 67. And when x is 8, the voltage is 72. And now you can just find your best fit. So always have a transparent ruler. Make sure the ruler runs equidistantly in between the points. Okay. So here I have my basic line. Not all of the points fit on the line. So yeah. So that's good. Now it says to determine the gradient. So looking at this, we're going to try to find points outside. And well, this one is already at the end here. So we're going to find a point maybe in here. Always make sure the lines intersect where you pass through. So we could quite possibly take this point, and we could take maybe this point. And we're going to label this y1, and so we're going to find the coordinates of this point, the y coordinates and the x coordinates. And so it's y1 is 65 volts, and y2 is 7.2 volts. And then y2 is 1, 2, 3 volts, and x2 is 0.3 volts. So now we're going to use these, and I like to tell my children, make sure you write your numbers on the graph, because you don't want to forget or make stupid or silly mistakes. I'm going to perforate the line now. And down here as well, because I want to perforate the line. For you, we want to get all 8 marks. So we're doing the line down here, and make sure you line up nicely. Okay, so now we have our perforated line, and we could find out the gradient of the line right now. The gradient is, they said it's S equal to delta y over delta x, and we could now say y1 minus y2 over x1 minus x. It's always rise over run. And we look for y1, so easy it is. We could look for y1 and put it here, 65 volts. And then we could look for our y2, which is 3 volts, divided by our x1, which is 7.2 volts, minus our x2, which is 0.3 volts. Now you get your nifty calculator, and you work it out now. So you could say 65, well, I put my brackets. 65 minus 3 divided by 7.2 minus 0.3. And you get approximately 0.99, and the volts cancel out, so I'm gonna say 9. So that is our gradient. Now we're gonna use that to answer these questions. So it says use the gradient S to calculate the number of turns in the secondary coil NS, given that the number of turns in the primary coil is NP. So we know the gradient, if the gradient S is equal to, if you look at it, the gradient was really Vs over Vp. So if the gradient was Vs over Vp and is equal to 9, then we could say then Vs over Vp equals, now we put and Vs equal to Ns over Np. We could put in our substitutions now. So we know that Vs over Vp is 9, and we know that Np, and we say and Np equal 85. So we know that Np is 85, then Ns, what is Ns? So Ns will be equal to, we're getting rid of the 85 on both sides. Ns will be equal to 85 times 9, and Ns will be equal to, there's no calculators, 85 times 9, 765. Okay? So that would be our number of turns in the secondary coil. Right? 765 turns. Then they said the current in the secondary coil IS, if the current in the primary coil IP is 1.8. So you know that will flip. So if you have NS over NP, remember it's Vs over Vp equal to Ns over Np equal to IP over Is. Or you could even write it like this: Vp over Vs equal to Np over Ns equal to Is over IP. So you could pick either which one. I'm going to pick this one, and I'm going to just use this in here. So I know that Ns is 765, and I know that Np is 85. So I'm going to say equal to IP. IP is 1.8 amps, and Is is what we're looking for, the current in the secondary coil. So we're going to cross multiply, and we're going to transpose basically. So we're going to say Is is equal to 1.8 amps times 85 over 765 equal to 1.8 times 85 divided by 765, you get 0.2 amps. Okay, which is great. Then now we're working out the power input, the power output P of the transformer, given that the voltage in the secondary coil Vs is 55. So power out will be equal to Is times IV, because remember P is equal to I times V, right? So we could now say P out is equal to whatever Is was. Is is right here, 0.2 amps. And then Vs is 55 volts. So P out is equal to, and you multiply it, 0.2 times 55, 11 joules per second, which translates to 11 watts. So that would have given you your 25 max. Then moving on, so those two are complete. Moving on to question 2. Question 2, it says complete, trying to clean up in here. So complete table 2 by inserting the appropriate by inserting the appropriate physical quantities and derived quantities. So by inserting, so yes, so we're going to insert the quantity and the derived quantity. So volume, they're looking for the SI unit. You cannot put centimeter cubed. They want the SI unit, which is meter cubed, right? Kilogram per cubic meter. This is actually kg over m cube, which translates to what you would use in the lab, grams per centimeter cube. It looks familiar, and yes, it is density. Remember, we only use this in the lab because the quantities we use are very small. So this is okay in the lab, but the SI unit is kilogram per cubic meter. Then the quantity for Newton is force. And then for pressure, we know that it's pascals. And it's also, if force is equal to force over, if pressure is equal to force over area, and the unit of force is Newton and that of area is meter squared, then this will be newtons per meter squared, or you could write it like this as well. Okay, so each of those are fine. So this one says a concrete block shown in figure 3 was made with cement. And so they give you the dimensions, 140. Pay close attention to the unit right there. So this is meters and this is meters. So we know we're going to keep this in, we're going to change this to meters. So all you had to do was look at the centi. The centi, a centi is equal to 10 to the negative 2. So you just multiply 140 by 10 to the negative 2. Or you could just divide by 100 and you get 1.4 meters, right? So it says calculate the density of the concrete block given that its mass is 2160 kilograms. Now they want you to use the units that they give you here, and you could see from just the units what to do. If you forgot how to calculate density, the units will tell you. You divide mass by volume. And we're going to first work out the volume. Volume of concrete block is equal to 1.4 meters times 2 meters times 3 meters. And that will give you 1.4 times 2 times 3. That will give you 8.4 meters cubed. Don't forget to cube the m. And now that you have your mass, you would say density is equal to mass over volume. So you have 20,160 kilograms divided by 8.4 meters cubed. And you just divide 20,160 divided by 8.4. You get 2,400 kilograms per cubic meter. Or you could write it 2,400 kg m minus 3. Moving on. It says define the term pressure. And pressure is this amount of force in newtons acting normally per unit area, where P is equal to force over area. So given that G is 10 newtons per kilogram, calculate the pressure exerted on the floor by the base of the block. So you want to find out the area of base of block, and the area would be this and that. So it's 1.4 times 2 meters. And that will give us 1.4 times 2, 2.8. 2.8 meters squared. And so we know pressure is equal to force over area, we have the mass. Once you have the mass, we have the mass here, which is 20,160 kilograms. We could convert it to force by multiplying it by this 10. So 20,160 kilograms times 10 newtons per kilograms divided by 2.8 meters squared. And so we're going to say 20,160 times 10 divided by 2.8, 72,000. So we get 72,000 newtons per meter squared, which translates to 72,000 pascals, which you could then write as P is therefore equal to 72 kilopascals. So you could write it like that. Okay? I think that ends question number 2. All right? Yeah?